Algae is really the biofuel that's going to dominate in the years to come, and that's because it's not based on a crop that people have to eat, and it doesn't use a lot of land. And so it really has this benefit to allow us to make lots of biofuels without getting in the way of arable land and the food supply of the world. Now, algae is potentially the fastest growing crop on Earth, but there's a technology challenge, and that's where OriginOils comes in. We're a pure technology company dedicated to a breakthrough technology to make algae cost competitive with petroleum. Petroleum, the world uses a cubic mile of petroleum every single year. That's a huge amount, and we have to think about the scale this represents. It's a huge amount of oil. And so how are we going to do this? How are we going to grow algae in so much? The answer is to industrialize it. We're going to have to industrialize the production of algae, no longer think of it as a crop, but as something like what you would do in a big brewery. And then we're going to have people make it everywhere, all over the world. It's going to be made by local partners and entrepreneurs and utilities and perhaps oil companies in every single region of the world. And that way we'll have this sort of mushrooms after rain concept of simultaneous rollout. Well, on your right and on your left, you see these light arrays. And what they're called is called photobioreactors. These are vessels where the algae grows and reacts with light and with CO2 and a small amount of nutrients to grow very quickly. And over here on the right are the small laboratory size reactors that we've been building. We've gone through 4 generations of these in the last year. We have half a dozen of these units in the shop right now that we're testing different variables. For example, recently this set of units was used to decide which proportion of lights would be just right for growing algae. And then on the left you see the 200-gallon bioreactor, which is about to be launched, which is our next scale up as we go towards ultimately 2,000 gallons and greater. So what we're doing with that one is really looking at how do the geometries work when you start to scale up the size. What about the spread of the lights and so forth? And there's a bunch of factors that enter into the equation. We could go straight to a very large tank and we'd be wasting our time until we know exactly how it works. These bioreactors don't just operate as a one-time engine. The challenge is to create a chain reaction of algae growth. Call it a daily bloom of algae. And algae can do that. It can be harvested daily. And so what you want to do is set up what we call cascading production, where we've really forced the growth of the algae, harvested it, made room for more algae on a daily basis. And that gives you kind of an engine, an algae industrial engine. And based on that, you can now have tremendous amounts of algae that you can split into oil and biomass. And of course, the oil can be broken into many uses, everything from gasoline to diesel, plastic, solvents, etc. We call it crude without the tar. And over on the other side, you've got the biomass, the remaining green stuff, and that can be gasified also into fuel and other products. So you have, an extraordinarily useful feedstock, almost like an energy battery that's constantly self-renewing, and then you can go ahead and convert it to fuel. Now, algae grows in what we call a carbon-neutral process. By that we mean that it sucks up CO2, it really lives from CO2, and so much so that it takes 2 tons of CO2 to make 1 ton of algae. And then, of course, when it is burnt, it releases that CO2 into the atmosphere. So it's beneficial because it's never pushing out more CO2 than it's using up. Compare that to petroleum, which of course it creates a huge carbon debt because it sucked up that CO2 long ago and now you're releasing it. And you're just going to put all that carbon in the atmosphere. And so by going over to algae, we can really, in a way, preserve our lifestyle by keeping cars and trucks on the road that are internal combustion engines, running jets and so forth on liquid fuel. And in a way, we can, not have to change the car right away because we're changing the fuel. And that's very important. OriginOil was launched in June of 2007 when we felt, along with some core investors, that the time had come to industrialize algae. And that was a very pioneering thought at the time. Today we really know that we've got to ramp up the scale of algae production so it can really compete with petroleum. And that was our vision, to create a breakthrough technology that could help algae compete with petroleum. Now, we are a pure technology company. By that we mean we do not want to compete with our customers and partners by trying to make lots of algae ourselves. Obviously we're going to be making trial quantities, but our plan really is to help our customers and partners make it all over the world, and for our headquarters here to be a knowledge center where we'll train and certify these partners, where we'll remote manage the network, make sure there's good quality, work with the carbon credits organizations to get certifications on these systems that we're building, and really to manage a network that is implementing algae production simultaneously all over the world. This is our testing pod, where we've had up to 3 Helix bioreactors ganged up with an automation system that you see over here, and it's allowed us to test the different variables. So we identical bioreactors, and then we're testing. For example, we just completed a series of experiments to determine what should be the ratio of blue to red and the small amount of white. And we've come out with that combination. We kind of like put that one to bed, and we'll be moving on to the next experiment. The Helix bioreactor is at the core of the OriginOil system because you've got to have very strong growth in order to make everything else work properly. We're working at a small scale here. These are 8-gallon bioreactors, and we like that because we can make lots of them, we can do lots of quick experiments, and we can scale that up very easily. What we've been working on lately is the red versus the blue and the white. Now, these bioreactors have some very specific features. The first one is, of course, that you've got layers of algae growth. As opposed to one on top, you've got growth in depth. The second thing, of course, is that these are turning, and the algae gets light when it wants it, which is only every few seconds, and this allows the light to be shared among many of the algae population. And of course, you've got this blue and red and white distribution, which is the algae prefers these wavelengths, and we've experimented with the combinations that work best. So, we're working our way through all these factors and determining the optimum configurations to make a very powerful growth engine. This is a growth chart from a week's period of algae growth, and each of these peaks represents algae rapidly growing as it absorbs CO2. It reaches a pre-programmed level at which the CO2 is introduced into the system, and then we have a period when the algae recovers and essentially what we call respiration, and then it reaches a level once again where it can absorb each time rapidly. Now remember that algae here is being grown on a 24/7 basis. Looking down here, we see the actual CO2 injections that are occurring on an automated basis. Because it's a 24/7 cycle, the algae doesn't have the night to recover. And in fact, what it's doing up here is, in these down periods, it's recovering and then able to start growing again. So we have very small cycles throughout our growing period all the way throughout this week. During this week-long period, what the algae has been doing here, in fact, has been absorbing CO2 and turning it into biomass, green stuff, and you might call this the magic of photosynthesis because we're turning this CO2 inert substance into something that's an actual fuel. These are the CO2 injections, this is the temperature graph, and these are the days at the bottom. This is an actual historical graph from one of our experiments. We're going to demonstrate how the quantum fracturing principle works to inject CO2 and nutrients into a growth vessel. So here we've got a bottle of CO2, and then in the middle of the screen right here is the mixing injector, and over here is the tank we're going to infuse with the CO2. Here we go. Okay, now the tank is completely filled with microscopic bubbles that the algae can feed on for quite a while. And you can see slowly some clarity is returning from the bottom. So we achieve about a 3-minute period during which the algae can feed on the CO2. This is the lighting array for the 200-gallon tank, our mid-sized prototype. And as you can see, these lamps are a lot longer, operating in a much larger volume of water than our 8-gallon tanks. As a result, our geometries will likely change and our processes will be modified. So right now we're making sure it's all working because it's going to be inserted in a tank and plumbed, and we'll get it to work soon.